In this problem, we're given the following circuit diagram. We're also given voltage for t is greater than or equal to 0. We are given the inductance, which is 50 millihenries. And then we are also given the current, which is I at t is equal to 0. So at the initial time is negative 5 amps. We need to find the time after 1 second. We do have a formula for this, and this formula is in the notes section 6.1, the inductor. And it's going to look like this. This is the formula that we are going to use to solve this problem. However, I'm going to change it up a little bit. This I of L at time is equal to 0, I'm going to move out to the front just so it's a little bit easier to read. We know for our L, we are going to be plugging in the 50 millihenries, or 50 times 10 to the negative cubed henries. And this is going to be over 1 because of our 1 here. We know our time, we want to find it at 1 second. For our V, we have 250 times sine 1000 t. And then for our I of L at t is equal to 0, we have 5 amps, a negative 5 amps. This is what our equation is going to look like. Now we're going to simplify a few things. First, I'm going to get rid of these zeros, and then I'm going to divide this 25 by 5, and then we get 5. I'm also going to make this 10 to the negative cubed moved up top, so it's just 10 cubed. And then I'm going to integrate our sine to 1000t. We know the integral for sine is negative cosine, so we are going to have a negative cosine and then 1000t over 1000. So now all we have to do is plug in our 1 and our 0. And this is what we're going to get for this equation. We're going to look at the farthest right side right here. We're going to have a plus. We know cosine to 0 is just 1, so we're going to have 1 over 1000 here. And now we can just plug all of this into a calculator. And if we carefully plug this into a calculator, we're going to get that our I of L is going to equal negative 2.8 amps. And that is the answer in how to do this problem. If you want more introduction to circuit analysis, there's a playlist and notes linked below. If you have any questions, you can leave them in the comments as well. So now all we have to do is plug in our 1 and our